Find the equation of the tangent to the curve. The equation of a tangent is a line. So the equation of a line is like any other equation of any line. So it has to pass through a point x1, y1, and we need to know the gradient of that line. So the equation of the line would be y minus y1 equals to m x minus x1. That would be the equation of any line. A tangent is a special line. It's a line drawn to a curve so that it touches the curve and it intersects a parabola exactly at one point, and the gradient of the curve at a particular point is equivalent to the gradient of the tangent. So the gradient of a tangent is dy by dx. So find the equation of a tangent to the curve y equals to x squared minus 7x plus 10, and the point is given, which is 2, 0. So in order to find the equation of a tangent line, we need to find the gradient of the curve first. So this is the curve and the point is 2, 0, and we have a tangent like that which is touching a curve. That's the line, and the gradient is dy by dx for that particular point 2, 0, because the gradient of a curve is different at different point. So this is the curve equation, y equals to x squared minus 7x plus 10. So y equals to x squared minus 7x plus 10. Now when we differentiate this, we have to differentiate both sides. So d by dx of y is the left hand side differentiation equals to d by dx of the right hand side, x squared minus 7x plus 10. So the derivative of y is dy by dx. When we differentiate something, the answer is known as the derivative. So the derivative of x squared is twice x minus 7x has a derivative of 7. So we found the gradient of the curve dy by dx. Now we have to find the gradient at the particular point where x has the value 2. The y coordinate is 0, but we don't need y to find the gradient here. So dy by dx, 2 into 2 minus 4, which is 4 minus 7 minus 3. We found the gradient of the curve at the particular point 2, 0, which is the same as the gradient of the tangent line drawn at that particular point. So that is going to be minus 3 also. Remember, the gradient of the tangent is equal to the gradient of the curve. Now we have to find the equation of the line. So the equation of any line is y minus y1 equals to mx minus x1. So y minus y1 is the y coordinate of the point. The gradient is minus 3, x minus x1 is 2. So x minus 2. So now let's simplify this. Y equals to minus thrice x plus 6. That's the equation of the tangent line, like any line. Now let me review the rules of derivatives a little bit. When you want to differentiate something, write d by dx, and the basic derivative is x to the power n. We write the exponent, and then we reduce the exponent by 1. For example, if x to the power 5, the derivative would be write 5 first and then reduce the number by 1, so x to the power 4. If it was x to the power 10, it would be 10. X to the power 9. If it was x to the power 20, it would be 20x to the power 19. Now let's do d by dx of a constant multiplied by that. It's just the constant multiplied with the derivative. If you have a number in front of the expression, just keep that number multiplied. That's all, and the derivative would be the same. When you differentiate a constant, the value would be 0 because derivative means change. But if you differentiate y, the answer would not be 0 because y is not a constant. Y is a variable. So it would be dy by dx, which is equivalent to change of y by change of x. Now let's do another one. Let's do b. So the curve here is y equals to x plus 1 by x. We have to write it as upstairs. We have to bring the variable upstairs. It becomes x plus x to the power minus 1. The rule of indices says if we bring the variable upstairs, the power becomes negative. So now we have to differentiate this. Derivative of y is dy by dx equals to derivative of x is 1. Now we have to know the rule of the basic derivative x to the power n. Remember, n comes first, so we'll write minus 1 first. Then we write x to the power, reduce the power by 1. So minus 1 minus 1. So minus 1 is minus 2. So you write 1, and we have plus into minus 1 is minus 1. Now it is always a wise idea to bring the value back to downstairs and make the power positive. So x is squared. We take it downstairs. That makes the calculation very simple. So we have the point 2, 2.5, which is 5 by 2. So let's imagine this is a basic rough idea of a curve, and we draw the tangent line at the particular point, which is 2 and 5 by 2. So we have to find the gradient at that particular point, 2, 5 by 2. Now let's find the gradient of the tangent at that point. So at x equals to 2, dy by dx, remember, just by writing it as a positive value 1 by x squared, it makes the calculation easier. 1 minus 1 by 2 squared, otherwise 2 to the power minus 2 is difficult to calculate. So 1 minus 1 by 4, that makes it 3 by 4. Now the gradient of the tangent is the same as the gradient of the curve. So gradient of tangent equals to 3 by 4. So let's find the equation of the line. Equation of the tangent line, we have y minus y1, which is 5 by 2. The y coordinate is 5 by 2. Then the gradient 3 by 4. Then we have x minus x1, which is 2. Let's cross multiply and make this, let's remove the fraction. So 4 into y minus 5 by 2 equals to 3 into x minus 2. Then we can multiply by 4, 4y minus 2 to the 4, 2 5 to 10, 10 equals to, so that's fine, equals to 3 into x is thrice x minus 2, 3 is a 6. So we can simplify it. It doesn't matter what format we write it. It's usually a good idea to write it in integer coefficient. That's good enough. Now let's find a one where we have an expression that needs to be simplified. Let's do number D. Y equals to 2x minus 1 divided by x. Now we need to simplify this. This is very, very important. We need to simplify this. So let's divide both part by x. So 2x divided by x minus 1 by x. This is very important. So we cancel x and we write 2 minus 1 by x. Now the reason we do this, and we have to write x to the power minus 1. We have to bring the variable upstairs. So when we differentiate y is dy by dx. When we differentiate the constant derivative is 0. And then we write minus, and the value of n, the power minus 1 comes in front. So, and then we reduce the power of x by 1. So minus 1 is minus 2. So minus into minus is plus, plus 1, and bring the positive downstairs to make it positive. So at the point 1, 1. So we have this curve again, just any arbitrary curve. That's not the exact curve, but for an idea it helps us. This is the gradient at a particular point. So we need to find the gradient. So at the point 1, 1, and this is the tangent that we are talking about. So at the point x coordinate is 1. So dy by dx equals to 1 by 1 squared, which is 1. So gradient of tangent is 1 because it is the same as the gradient of the curve. So equation of tangent is y minus y1, which is the y coordinate, which is 1 because the point is 1, 1. The second one is the y coordinate. 1 is the gradient x minus x1. Let's simplify. Y minus 1 equals to x minus 1. And the y equals to x because the minus 1 and the minus 1 cancels. Now this one we have to find the equation of the normal. A normal is another special type of a line with relationship to a curve. It is like perpendicular to that particular point on the curve. And for a tangent, the gradient is the same as the gradient of the curve at that particular point, because the gradient of curve is different at different points. For that particular point, the gradient of the curve is dy by dx. For the tangent, it is also dy by dx throughout, because the gradient of a line is fixed. The gradient of a curve changes from point to point. In case of a normal, so let's call this m1 and let's call this m2. In case of a normal, the gradient is a reciprocal, meaning 1 divided by that gradient, but also negative. It is also negative gradient. So minus 1 by dy by dx is the gradient. So if 2 is the gradient of the curve at that particular point, the gradient of the normal is minus 1 by 2. If 3 is the gradient, then minus 1 by 3 is the gradient of the normal. If 4 is the gradient of the curve, then gradient of the normal is minus 1 by 4. So that's the relationship of negative reciprocal. Reciprocal means 1 divided by some other number. That's the idea of reciprocal. And at that particular point, dy by dx is the gradient of the curve. So let's do this. Y equals to x squared minus 8. Now let's bring this x to the power, square root of x means x to the power half in index form. So we can bring it upstairs, x squared minus 8. X to the power minus half it would be if we take it upstairs. So that's the simplified format. We need to simplify things. That's very, very important before we can start differentiating it. It is one of the most important rules of gradient. It is the addition or subtraction rule. When you differentiate something and if there is some plus or minus sign between variables, you just write down the derivative and put down the plus or minus sign as it is. It's a rule. It's a rule of differentiation. It's the addition or subtraction rule. That's what we have been doing. It might seem very obvious, but it's a rule that we must follow. So when we individually differentiate it, so if we differentiate y on this side, dy by dx is the derivative. Now when we differentiate x squared, so the derivative is twice x. Then addition rule says, or subtraction rule says, we just write the minus sign, whatever is there, and we differentiate the next term. So 8 is the constant will be there, rule the derivative, constant rule of derivative, and then we write the n, the power of x here in front. So minus half comes in front, and x, the power minus half will reduce by 1. So minus half minus 1. So twice x. Now minus 8 into minus half, if you multiply it, it would be plus 4. And x to the power minus half minus 1 is minus 3 by 2. So minus 3 by 2 is the exponent of the power. So now we have to make it positive. It's a good idea because otherwise calculation becomes complicated. X to the power 3 by 2. Now let's find the gradient. Remember to have an idea of what it looks like. This is not the exact sketch, but roughly speaking, if this is a parabola and this is the normal. A normal is like a stab. You stab something, and a tangent is like a slap. It touches it. So at that point, gradient is dy by dx, and the point is 4, 12, and the gradient of the normal is minus 1 by dy by dx, negative reciprocal. So at the point x equals to 4, at that point the value of x is 4. So dy by dx is 2 into 4 plus 4 divided by 4 to the power 3 by 2. And we can use indices. So 2 4 is 8 plus 4 divided by, now 4 to the power 3 by 2 means 2 squared to the power 3 by 2. So when you have a power over a power, you multiply the power and you get 8 plus 4 divided by 4 cubed is 8. So 8 plus half, 4 by 8 is half. So 8 and a half means 2 8 is 16 plus 1, 17 by 2. That is the gradient of the curve. Remember, the gradient of the normal is going to be not only the reciprocal but negative reciprocal. It would be minus 1 by 17 by 2. That would be minus 2 by 17. That is the gradient of the normal. Now let's find the equation of the normal line. Y minus y1 equals to mx minus x1. So equation of normal, that means we're going to write the point is 4, 12. So y minus 12, the y coordinate. So remember that rule. The tangent has the same gradient. The normal has minus 1 by m2, and the equation of a line is going to be y minus y1. So y minus 12 equals to m, which is minus 2 by 17, x minus x1, which is 4. Let's simplify this. Multiply the left hand side with 17. So 17 into y minus 12 equals to minus 2 into x minus 4. So we have 17 into y minus, now 17 into 12, it's supposed to be 200 something. So let's do this. 17 into 12, and that is 204. So let's put it 204 equals to minus twice x plus 4 2s are 8. So we can keep it a simplest form. Otherwise, sometimes it is mentioned in what format your equation should be. Unless it is mentioned, just leave it in any form you want. That's not a problem.